name is Petr Blaho. I work at Red Hat. I was a PyVo developer. And I will not have a talk, not a lightning talk. It will be just information about that mutation testing exists and what it is. And maybe we'll start some discussion and inform some people who do not know what it is. So, what is the purpose of the testing in general? We can have some acceptance testing, like Cucumber in Ruby or Lattice in Python, which is good to ensure that our application really does what we or customer wants. We can do this the same in our spec or other tools. We can write integration tests to see how the different parts of application works together. We can write unit tests to see if every small and simple part of application works. And this is every kind of usage of these tests is like beforehand, because you are just writing tests and then you are writing code, or you are writing code and writing tests, but it's every time to see if my test works. When someone finds a bug, you have to write a test for that bug and then repair it. When this happens, this means that your tests are not good enough, because you have some coverage, some tests, and the bug is there, even if you are trying 100% coverage.
Literally security bugs, sorry to interrupt. The security bugs are out of the unit test and integration test. They are related to security, so you have to really alter your code. And
yeah, but that's the scope of this.
Yeah, sorry.
So, what mutation testing do? Is there anyone who do not know what is abstract syntax tree?
I don't have any idea.
Yeah, I believe it. So, really simply, imagine that your code is just represented by a syntax tree. Just every step is a pointing tree, and you can just make your algorithm in one picture. And mutation testing works in the way that it just grabs these points, like if statement, every operator is a pointer there, and tools for mutation testing just swaps these points with some other. Maybe you are just adding two integers, so a mutation testing tool just swap to subtracting one integer from another, and then run your test against this modified code, this modified program. And the simple idea is that if these tests do not fail, so your test is a gap, because they do not test modified code. So mutation testing leads you to write every single possible test case to make sure that if in future your code will change, the test will break. If it is useful, I will let you to think out about it. So let's see some sample. This is just a few methods in Python. I have written some code, some tests, and I will just run the mutation testing u.py, and in the end we have. Do you see? No.
We'll just make terminal smaller.
Yeah. It's bad in tiling Windows Manager. Okay, so we have a mutation score here. We have 3 mutations and 2 killed that means that mutation was killed by a failing test. And one survived. Maybe it screams. So we have the test here, or the code. It's a repeat function. Not really sure if you can see it. And the test for it is just a simple assertion that so you can see changes in the code. So this is the original code. This is the code without the statement in for cycle.
And that's still somewhere.
Sorry?
And it's still so the problem is when the test passes, even though you're
Yeah, the problem is that test passes for the mutated code. I will show you another one. Scope a little.
Jo, ještě?
Ještě? More?
No, nevidí, jo.
Sorry, I do not remember all the mutates or mutators.
Don't worry, we can see.
Okay, can you see the add method mutated? This one of the, there's a plus here, original one, there's a minus here, and the idea is that you have to write a test to ensure all mutations is killed. You will just delete some code because I do not know how it is visible. So we have original code is multiplication. We do not see of two numbers, and our test is just that 2 times 2 is 4, which is not enough because we have one of the mutations. Here, the last one. Because test passed, your test, my test is not good enough, so list of mutation operators it supports, and as you can see, it's not really everything you can just imagine when you are writing or mutating your code.
Can you run it with all the mutators at once?
Yeah.
And so if we were to like put back the code that there wasn't all the unit tests that you had there, I'm quite interested in how much mutation would it kill of all those mutators.
That code original or
yes,
this one just for multiply?
The original test, all the tests and all the methods.
So we have 48 mutations and killed only 91, so...
What does incompetent mean?
I'm sorry, I do not know. Because I didn't see incompetent in other tools. So still not really sure what does it mean in Py. So the question for you, I will not be answering. I will be asking if anybody think that this can be useful.
I think it can be useful for certain types of programs, less useful.
Or maybe libraries.
Yeah. And I have a question. Have you looked into like how this stuff will work in statically typed languages? Because I'm guessing there's a lot of issues with how.
I'm not really sure.
Is there an example of this for statically typed languages?
I don't know because I work in Ruby and Python, so I focus on these two languages.
Statically typed languages use something else.
There's something like this for Java, because Java also uses byte code which can be manipulated. But generally they use other tools instead. This is most commonly just swapped out for randomized testing.
Yeah, like fuzzy testing.
Yes.
Yeah, but
Throw whatever.
the randomized testing is like you are putting there different data, right?
Now, it's you're basically always you're auto-generating the configuration and the layout and everything differently each time. So, for example, for us, Sales Research is a distributed database, so we always randomize the number of nodes, the size of the machine, the different versions. Not just the data.
But it's still like, it's still a configuration like the input. This kind of thing is actually changing the source code.
Yes. So yes, but the idea
like something like deleting those exception handle from the pieces of code would be kind of fun. Yeah, for statically typed language, they're using something like mathematical proofs and automatas and something like that, because it would be actually proved that the program will end and the program has infinite number of states and something like that. So
that's the famous quote. Beware of this algorithm and then run it.
yeah, the typo.
So when you find out that 100% of test coverage is not enough, so you can just start mutating your code.
You need 200%.
Yeah, maybe more.
I would say like 1,000.
For anybody interested in testing, I would suggest looking at SQLite's test suite. SQLite has a ratio of 1,000 to 1 lines of tests compared to lines of code. That's how the company makes money.
Yeah.
Because SQLite is free, but when you want to implement it on your platform, you have to pay them for the test suite. And they do crazy things. For example, they do all the fuzzy testing and everything, and they are constantly inventing new ways to measure the coverage, not just line coverage, but they have now complete branch coverage and everything. And they're still trying to do new stuff. So they have over several millions of tests. Some of them generated that they actually run. It's really scary.
Crazy.
Okay, any other question or? Okay, thank you.